Hello and welcome. Today we're going to talk about one of students' least favorite topics in math class, and that's trig functions. Most students are fairly familiar with trig functions, and they're aware that we have three basic trig functions of sine, cosine, and tangent theta. Most students probably even know their basic definitions, but today we are going to talk about what these trig functions actually mean. In other words, when I put sine of 30 degrees into my calculator, why do I get 1/2? So in order to answer that question, we first have to look at the unit circle. It's important that we understand how to use the unit circle. If you recall, the unit circle is simply a circle that's drawn on an XY coordinate system that has a constant radius that equals 1. In other words, this point right here, where the unit circle intercepts the x-axis, is going to have a coordinate of 1, 0. And this point up here that intercepts the y-axis is going to have a coordinate of 0, 1. The same is true for these other 2 points for the negative x-axis and the negative y-axis. But to really look at sine and cosine, let's first draw a radius that extends out to the unit circle. And then I'm going to drop a vertical down from that point of intersection where that line intersects the unit circle. This point is really what I'm concerned about. And so of course, this line is drawn with a certain angle, theta, that measures between the x-axis and our line. This creates a right triangle, and this right triangle has 3 important parts. The first part is the hypotenuse, and because the hypotenuse is simply the radius of the circle, we know it has a length or a distance of 1 unit. We also have the side of the triangle that's directly across from the angle, and because it's directly across, we call this the opposite. And then the third side of the triangle, this bottom one, is called the adjacent. Now hopefully these terms look very familiar from our trig functions that we defined at the very beginning.
So now let's look at how this definition of a right triangle directly relates to our trig functions. So let's first start with our very first trig function of sine theta. And we said sine theta equals opposite over hypotenuse. And so what that actually means is that when we draw a line, a radius to the unit circle that has an angle measurement of theta, the length of the opposite side of the triangle, which is this side right here, divided by the length of the hypotenuse will equal sine theta. And so we know the length of the hypotenuse will equal 1. So in other words, sine theta is simply going to equal the length of the opposite side of the triangle. So sine theta is just going to equal this length right here. We can do the same thing with cosine, and that cosine theta equals adjacent over hypotenuse. And so the adjacent side is this side right here. And so cosine theta is just going to equal this length, adjacent, divided by our hypotenuse, which again is 1. So that means our cosine theta is simply going to equal the length of the adjacent side of the triangle. So sine describes the vertical side of the triangle, adjacent describes the horizontal side of the triangle. So with this in mind, we can come up with the definition for this point P, we'll call it point P, is just going to equal cosine theta sine theta. And this will be true for any point on this circle. Even if it's in a completely different quadrant, if we draw a line out to it that measures an angle theta from the x-axis, the coordinates of this point will equal cosine theta sine theta. So that's what sine and cosine actually mean. And so with that in mind, I want you guys to come up with a similar definition for tangent theta.